The silent universe. Welcome to cosmic depths. Today we're venturing into territory darker than the event horizon of a black hole, more distant than the edge of the observable universe, and far more disturbing than any cosmic catastrophe. We're confronting one single question that has haunted scientists, philosophers, and stargazers for over 7 decades. If the universe is 13.8 billion years old, contains 2 trillion galaxies, and trillions upon trillions of potentially habitable worlds, why does it remain completely, utterly silent? The weight of absence. Imagine standing on a beach at midnight. The ocean stretches to the horizon in every direction. Waves crash rhythmically against the shore. Seagulls cry overhead. Somewhere in the distance, a ship's horn sounds faintly through the fog. Now imagine that same beach, but every sound vanishes. No waves, no birds, no ships. Just you standing alone in absolute acoustic darkness. That's the sensation of scanning the cosmos. Every star you see through your telescope represents a potential solar system. NASA's Kepler mission discovered that 20 to 50% of Sun-like stars have Earth-sized planets in their habitable zones. The James Webb Space Telescope is currently analyzing the atmospheres of distant worlds for biosignatures. Oxygen, methane, water vapor. The math suggests life should be everywhere, but when we listen, nothing. No radio beacons, no laser pulses, no engineered megastructures dimming stars in detectable patterns, no trace of industrial pollution on exoplanet atmospheres, just the hiss of cosmic background radiation and the occasional burst of natural astrophysical noise. This deafening absence earned its name in 1950 during a casual lunch conversation at Los Alamos National Laboratory. The moment Fermi asked it was July 1950. The Manhattan Project's brightest minds had gathered for a picnic. Nobel laureate Enrico Fermi sat eating lunch with fellow physicists Emil Konopinski, Edward Teller, and Herbert York. Somehow the conversation turned to UFO reports and recent science fiction magazine stories about flying saucers. Fermi grew quiet. He stared into space for a moment, then asked his famous question: "Where is everybody?" What followed was one of history's most devastatingly simple calculations. Fermi estimated the Milky Way contains about 100 billion stars. Assume 1% have planets. Assume 1% of those have habitable worlds. Assume 1% develop life. Assume 1% of those evolve intelligence. Assume 1% survive long enough to become spacefaring. Even with these ultra-conservative numbers, Fermi calculated there should be 10,000 detectable civilizations in our galaxy alone. The galaxy is only 100,000 light-years across. Radio signals travel at light speed. Even at a leisurely 1% of light speed, spaceships could cross the entire Milky Way in 10 million years, a blink compared to the galaxy's 13 billion-year age. So where is everybody? SETI's 60-year hunt. Since Fermi's question, we've built instruments specifically to answer it. Project Ozma in 1960 pointed the world's largest radio telescope at 2 nearby stars, Tau Ceti and Epsilon Eridani, listening for 10 watts of signal power, less than a household light bulb. Nothing. The search for extraterrestrial intelligence, SETI, grew from there. By the 1990s, the Allen Telescope Array scanned millions of stars across 20 million channels simultaneously. The breakthrough. Listen Project, funded by Yuri Milner with $100 million, now examines 1 million nearby stars and 100 galaxies using the Green Bank Telescope and Parkes Observatory. In 1977, we almost had our answer, the WOW signal. On August 15, 1977, Ohio State University's Big Ear Radio Telescope detected a 72-second burst of radiation at 1420 MHz, the hydrogen line, a frequency any advanced civilization would know we monitor. The signal was so extraordinary that astronomer Jerry Amon circled it on the printout and wrote, "Wow," in red ink. The signal never repeated. Despite decades of re-observation, its origin remains unknown. Natural explanations range from passing comets to atmospheric phenomena. Extraterrestrial origin remains possible, but unproven. We've also looked for optical signals. Lasers are far more efficient than radio for interstellar communication. The Laser SETI project now monitors the entire northern sky continuously for brief, intense pulses that would indicate deliberate targeting. Still, nothing conclusive. 8 possible explanations. 1. The Great Filter, Rare Earth. Hypothesis. Life might be common, but technological civilization is a 1 in a trillion fluke. Earth required a precise sequence: plate tectonics for carbon cycling, a large moon stabilizing axial tilt, Jupiter clearing asteroid impacts, a magnetic field blocking cosmic rays. Change any parameter and intelligence never evolves. 2. The Great Filter, Self-Destruction. Maybe every civilization reaches a critical threshold: nuclear weapons, climate engineering, nanotechnology, artificial superintelligence, and destroys itself. Carl Sagan warned we might be a species that finally figured out how to kill ourselves, just as we learned there might be others out there to talk to. 3. Zoo Hypothesis. Advanced civilizations exist but deliberately avoid contact, observing us like animals in a nature preserve. They enforce a galactic prime directive, intervening only if we pass some unknown test or reach a specific technological milestone. 4. Simulation. Hypothesis. We're living in a computer simulation. Advanced beings run ancestral simulations containing all possible civilizations. Real extraterrestrial intelligence exists, but only as programmers who don't interact with their creations. 5. Dark Forest Hypothesis. Space is a dark forest filled with hunters. Every civilization stays silent because broadcasting reveals your position to potential predators. Liu Cixin's novel The Dark Forest argues this explains the Fermi paradox perfectly. Survival demands silence. 6. Communication. Mismatch aliens might use neutrinos, gravity waves, quantum entanglement, or entirely new physics we can't detect. Or they communicate locally via modulated pulsar beams or planetary-scale lasers that appear as natural phenomena to us. 7. Temporal disparity. Maybe we're too early. Stars near galactic center formed first and may host civilizations billions of years ahead. Or we're too late. Most civilizations peaked 5 billion years ago and went quiet. We're shouting into an empty lecture hall after class ended. 8. They're already here, but invisible. Dyson spheres, stellar engines, and matryoshka brains might exist but be undetectable with current technology. Type 2 civilizations, harnessing entire stars, produce waste heat signatures we've never observed. The most disturbing implication. Perhaps the true answer combines several factors. Life emerges frequently, intelligence evolves occasionally. Technological civilization arises rarely. Longevity proves nearly impossible. If the Great Filter lies ahead of us, nuclear war, climate collapse, AI misalignment, engineered pandemics, then Fermi's silence becomes humanity's warning. Every day we survive moves the filter farther into the future. Every technological breakthrough either brings us closer to interstellar capability or self-destruction. What we're doing about it. Modern SETI has evolved dramatically. James Webb Space Telescope analyzes exoplanet atmospheres for dimethyl sulfide, phosphine, technosignatures. Europa Clipper, launch 2024. Searches Jupiter's moon for subsurface ocean life. Dragonfly drone explores Titan's organic chemistry, 2034 arrival. China's FAST telescope scans 2,000 stars daily across 19 frequency beams. Breakthrough starshot plans. Laser-propelled nanocraft to Alpha Centauri at 20% light speed. The philosophical weight. The Fermi paradox forces confrontation with our cosmic insignificance. We're not questioning distant aliens. We're questioning our trajectory, longevity, and ultimate fate. If we're alone, life becomes infinitely more precious. If we're early, we bear responsibility as cosmic pioneers. If we're average, something prevents longevity. If we're late, we missed the galactic party. Every scenario demands we take ourselves seriously, not as conquerors, but as improbable, fragile experimenters in a silent universe. The final question. Maybe the silence isn't failure. Maybe it's preparation. Maybe every civilization faces Fermi's question and chooses restraint. Maybe galactic society requires proving maturity before joining. Maybe we're not ready. Or maybe the silence means something simpler and more beautiful. We get to be first. When you look up tonight, remember, that silence overhead might not mean abandonment. It might mean anticipation. It might mean the universe paused, waiting to hear from us. If this journey through cosmic silence moved you, subscribe to Cosmic Depths. The universe still holds countless mysteries, and we're just getting started.